Hello my dear student. Last class we discussed about the various properties exhibited by colloidal solution. So first one is colligative property. First one, colligative properties. Second one, Terdal effect. Okay, so now tell me about colligative properties. So here the colligative particles are bigger aggregates. The number of particles in colloidal solution is less as compared to the particle present in true solution. Hence, the colligative properties like osmotic pressure, elevation boiling point, depression in freezing point are lesser value as compared to value of true solution at same concentration. So here this is about the colligative property. See ನೋಡಿ colloidal solution ಏನಾಗಿರುತ್ತೆ colligative particles ಏನು ಮಾಡ್ತಾವೆ ಬಿಗ್ಗರ್ ಅಗ್ರಿಗೇಟ್ ಅಂತಂದ್ರೆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದೊಂದು ಏನು ಮಾಡ್ತಾವೆ ಕೂಡ್ತಿರ್ತಾವೆ ಹೌದಾ. ಸೊ ಕೂಡೋದ್ರಿಂದ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತವೆ colloidal solution ದಾಗ ಕಡಿಮೆ ಆಗ್ತವೆ. ಯಾಕಂದ್ರೆ ಅಂದ್ರೆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನು ಮಾಡ್ತಾವೆ ಒಂದೊಂದು ಮಾಡ್ತಾವೆ ಅಟ್ಯಾಚ್ ಆಗತ್ತವೆ ಅಗ್ರಿಗೇಟ್ ಆಗತ್ತವೆ ಹೌದಾ. ಸೊ ಅದಕ್ಕೆ ಏನಾಗ್ತೈತಿ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಕಡಿಮೆ ಆಗ್ತವೆ. ಸೊ ಹಿಯರ್ ದ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇನ್ colloidal solution is less as compared to true solution. ಅಂದ್ರೆ ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ ದಾಗ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವಲ್ಲ ಅದಕ್ಕಿಂತ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ colloidal solution ದಾಗ ಕಡಿಮೆ ಇರ್ತಾವೆ. ಸೊ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ colloidal solution ದಾಗ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ colligative property colligative property ಯಾವ್ಯಾವು ಒಂದು osmotic pressure, elevation boiling point, depression in freezing point, etc. So here the value of these property less in case of colloidal solution as compared to true solution. So this is about the colligative property. The next one is Terdal effect. What do you mean by Terdal effect? So here the phenomena of scattering of light by colloidal particle. This is called as Terdal effect. Phenomena of scattering of light by colloidal particle is called Terdal effect. So third one is Brownian movement. Third one is Brownian movement. So here the colloidal solutions are observed under powerful ultra microscope. Colloidal solution observed under powerful ultra microscope. The particles of colloidal solution under state of continuous motion. So here the particles of colloidal solution under state of continuous zigzag or random motion. It was first observed by Robert Brownian in the year 1827. So colloidal particle na now microscope observe ಮಾಡಬೇಕು. ಎಂತ microscope? The powerful ultra microscope. Observe ಮಾಡಿದಾಗ the particle state ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ zigzag movement ದಾಗ ಏನಂತ particle movement ಆಗ್ತಿರ್ತಾವೆ. Then first ಯಾರು observe ಮಾಡಿದ್ರು ಅಂದ್ರೆ ರಾಬರ್ಟ್ ಬ್ರೌನ್ ಅಂತಕ್ಕಂಥ scientist in the year 1827 ಆಗಿ ಮಾಡಿದ್ರು observe ಮಾಡಿದ್ರು. Then what is called Brownian movement? So here Brownian movement means zigzag or random movement of colloidal particles in colloidal solution. So here the phenomena in which the zigzag or random movement of colloidal particle in colloidal solution is known as Brownian movement. Okay, so Brownian movement ಅಂದ್ರೆ ಏನ್ರಿ colloidal particles ಹೆಂಗ್ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತಾವು zigzag ಅಥವಾ random movement ಆಗಿ ಮಾಡ್ತಾವು ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತಾವು. ಸೊ random motion ದಾಗ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತಾವು ಎಲ್ಲಿ ಪಾಸ್ colloidal solution ದಾಗ ಅದಕ್ಕೆ ಹೆಂಗ್ ಕರೀತೀವಿ here, consider. So this is a zigzag motion of colloidal particle. So here, zigzag or random movement of colloidal particle in a colloidal solution is known as Brownian movement. So here, the Brownian movement does not depend on nature of colloidal particle. It does not depend on upon nature of colloidal particle, but it depends on size of colloidal particle, and viscosity of dispersion medium. So Brownian movement ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತೈತಪ್ಪ ಅಂದ್ರೆ ನೇಚರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಂಗಿಲ್ಲ, ಹೊರತಾಗಿ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತೈತಪ್ಪ ಅಂತಂದ್ರೆ size of colloidal particle and viscosity of dispersion medium. So here Brownian movement depends on size of colloidal particle and viscosity of dispersion medium. So here, the smaller the particle and lesser the viscosity of dispersion medium. Smaller the particle, lesser the viscosity of dispersion medium, the movement of colloidal particle is high. The movement of colloidal particle is high. ನೋಡ್ರಿ, the colloidal particle movement ಯಾವಾಗ ಜಾಸ್ತಿ ಇರಬೇಕಪ್ಪ ಅಂದ್ರೆ colloidal particle size ಅಂದಿರಬೇಕು, ಆಮೇಲೆ viscosity of dispersion medium ಇರಬೇಕು, ಕಡಿಮೆ ಇರಬೇಕು. ಅವಾಗ ಏನಾಗ್ತೈತಿ, the movement of colloidal particles ಏನಾಗ್ತೈತಿ higher. Okay, so here the colloidal particle, the Brownian movement depends on or it occurs. The Brownian movement occurs the collision of molecules of dispersion medium with colloidal particle. So here Brownian movement occurs by interaction or collision with molecules of dispersion medium with colloidal particle, and also occurs by repulsion of similar charge particle. So Brownian movement ಹೆಂಗೆ occur ಆಗಪ್ಪ ಅಂದ್ರೆ collision ಆಗುತ್ತೆ. ಏನು collision ಆದಾಗ molecules of dispersion medium ಆಮೇಲೆ colloidal particles ಒಂದು collision ಆಗಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ Brownian movement ಏನು ಮಾಡ್ತೀವಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಅದಷ್ಟೇ ಅಲ್ಲ, ಯಾವಾಗ ಎರಡು ಸಿಮಿಲರ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ಸ್ ರಿಪಲ್ಷನ್ ಆಗ್ತಾವೆ, ಸೊ ರಿಪಲ್ಷನ್ ಆಗಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ Brownian movement ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. So here, this is about the Brownian movement. So this Brownian movement is the third property of colloidal solution. So here, tell me what do you mean by Brownian movement? Brownian movement is zigzag or random movement of colloidal particle in colloidal solution is known as Brownian movement. So here, the Brownian movement does not depends on nature of colloidal particle, but it depends upon size of colloidal particle and viscosity of dispersion medium. So here, smaller the size and lesser the viscosity of dispersion medium, the movement or motion of colloidal particle is high. Next one, the Brownian movement occurs when collision of molecules of dispersion medium with colloidal particle take place, and also by repulsion of same charged particles, and also formation of Brownian movement takes. So next, fourth property is charge on colloidal particle. So here, the colloidal particles always carries an electric charge. Colloidal particle always carries an electric charge. The nature of charge is same for all the colloidal particle in a given colloidal solution, or it may be positive or it may be negative. So here the some common solution with particles of charge here. Positive charge solution, here negatively charged solution. So in case of positive charge solution, hydrated metal oxide, hydrated metallic oxides. For example, aluminum oxide, ferric oxide, aluminum oxide and ferric oxide. In case of negative charge solution, metals like gold, silver, platinum. Next, second one, hemoglobin. So already know hemoglobin is present in blood. And in case of negative charge solution, metallic sulfide, metallic sulfide. Example, arsenic sulfide and cadmium sulfide. Arsenic sulfide and cadmium sulfide. Third one, basic dark stuff. Basic dark stuff. Example, methylene blue. Example, methylene blue. So in case of negative charge solution, acidic dye stuff. Acidic dye stuff. Example, Congo red. Congo red. And fourth one, oxides of solution. For example, titanium oxides. Titanium oxides. In case of negative charge solution, gum, gelatin, clay, etc. So here, four properties: charge on colloidal particle. So here, the colloidal particles always carries an electric charge. Illudri, or colloidal particle always electric charge na hondirtave. The nature of charge is same for all the colloidal particles in given colloidal solution. So note, charge of colloidal particles same irbodu. Illappa antandre it may be negative or it may be positive. So here, the some solution or some common solution with a charge of particles are here. So note, ಕೆಲವೊಂದು ಸೊಲ್ಯೂಷನ್ ನಾವು ಮಾಡಿದ್ರೆ ಕಾಮನ್ ಸೊಲ್ಯೂಷನ್ ಇಲ್ಲಿ ನಾವು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡಿ ಬರಬೇಕು. ಯಾವುದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸೊಲ್ಯೂಷನ್ ಒಂದು, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಸೊಲ್ಯೂಷನ್ ಒಂದು. ಸೊ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಹೈಡ್ರೇಟೆಡ್ ಮೆಟಲಿಕ್ ಆಕ್ಸೈಡ್. ಹೈಡ್ರೇಟೆಡ್ ಮೆಟಲಿಕ್ ಆಕ್ಸೈಡ್ ಅಂದ್ರೆ ಏನು? ಇಲ್ಲಿ ಈ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಒಳಗೆ ಏನಿರುತ್ತೆ? ವಾಟರ್ ಇರುತ್ತೆ. ಅದನ್ನ ಏನು ಕರೀತಾರೆ? ಹೈಡ್ರೇಟೆಡ್ ಮೆಟಲಿಕ್ ಆಕ್ಸೈಡ್. ಎಕ್ಸಾಂಪಲ್ ಯಾವುದು ಐತಿ? ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್, ಫೆರಿಕ್ ಆಕ್ಸೈಡ್. ಓಕೆ. ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಮೋಗ್ಲೋಬಿನ್ in presence of blood. Third one is basic dark stuff. So we know that is coloring agent. Example, methylene blue. So already we know about the methylene blue. So here methylene blue, due to methylene blue, our ink is blue in color. So next, fourth one, oxides of metals. For example, titanium oxide. In case of negative charge solution, metals like gold, silver, platinum, these all metals belongs to negative charge solution. Second one, metallic sulfide. For example, arsenic sulfide and cadmium sulfide. Fourth one, acidic dark stuff. For example, Congo red. Fourth one, gum, gelatin, clay. These all belongs to negatively charged solution. So here, the presence of equal and similar charge on colloidal particle. Presence of equal and same charge on colloidal particle is largely responsible for stability of colloidal solution. between similar charges, because repulsive force between similar charges prevent to form aggregate, prevent from aggregate. So ನೋಡ್ರಿ colloidal solution ಒಳಗ equal ಮತ್ತು ಸೇಮ್ ಚಾರ್ಜ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಆ colloidal particles ಏನ್ ಮಾಡ್ತಾವಪ್ಪ ಅಂದ್ರೆ ಎದಕ್ಕೆ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಆಗಿರ್ತಾವಪ್ಪ ಅಂತಂದ್ರೆ colloidal solution ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾವ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಇರ್ತಾವ. ಯಾಕಂತಂದ್ರೆ ಸಿಮಿಲರ್ ಚಾರ್ಜ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ರಿಪಲ್ಷನ್ ಫೋರ್ಸ್ ಇರೋದು ಜಾಸ್ತಿ ಇರ್ತದೆ. ಸೊ ರಿಪಲ್ಷನ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಅಲ್ಲೇನಾಗಂಗಿಲ್ಲ, ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದು ಕೂಡಿ ಅಗ್ರಿಗೇಟ್ ಫಾರ್ಮೇಷನ್ ಆಗಂಗಿಲ್ಲ. ಸೊ ಹಿಯರ್ the presence of equal and same charge on the colloidal particle is largely responsible for stability of colloidal solution, because repulsive force between similar charged particles to prevent form aggregate. So here charge on colloidal particle is due to one or more reasons. So first one is due to capture of electron by solution particle during electrodispersion of metal. And second one, formation of electrical double layer. So ನೋಡಿ ಎರಡು ರೀಸನ್ ಅದಾವು colloidal particle ನ ಚಾರ್ಜ್ ಬರಬೇಕು ಅಂತ. ಒಂದೇ ರೀಸನ್ ಏನೈತಿ, ಡ್ಯೂ ಟು ಕ್ಯಾಪ್ಚರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ by solution particle during electrodispersion of metal. So what do you mean by electrodispersion of metal? So here the conversion of metal into colloidal form with help of electricity in a suitable solvent is called as electrodispersion of metal. Electrodispersion of metal ಏನಪ್ಪ ಅಂತಂದ್ರೆ metal ಇಂದ colloidal form convert ಆಗುತ್ತೆ with the help of electricity ಎಲ್ಲಿ in suitable solvent. Okay, ಇದನ್ನ ಏನು ಕರೀತಾರೆ, electron dispersion of metal. So now consider metal, it is dipped in suitable solvent. We apply electric current, and this beaker, it is kept in freezing mixture. When we apply electricity at high electric current, so here the metal are converted in vapor state. These vapor states are entered into stable solvent. Now aggregation is take place. So here aggregation is take place. At high current, the electrons are absorbed by these particles. So this is called as electron dispersion of metal. So ಏನು ಮಾಡಬೇಕಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಮೆಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಂಡೆವು, ಅದನ್ನ ಏನು ಮಾಡಿದೆವು ಸ್ಟೇಬಲ್ ಸಾಲ್ವೆಂಟ್ ಒಳಗೆ ಡಿಪ್ ಮಾಡಿದೆವು. ಸೊ ಈ ಸಾಲ್ವೆಂಟ್ ನಲ್ಲಿ ಮಾಡಕ್ಕೆ ಒಂದು ಫ್ರೀಜಿಂಗ್ ಮಿಕ್ಸರ್ ಆಗಿ ಮಾಡಿದೆವು ಇಡಕ್ಕೆ. ಹೌದಾ, ಇಲ್ಲಿ ಏನು ಮಾಡಕ್ಕೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅಪ್ಲೈ ಮಾಡಕ್ಕೆ. ಹೌದಾ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಮೆಟಲ್ ವೇಪರ್ ಸ್ಟೇಟ್ ಏನು ಮಾಡ್ತೀವಿ ಕನ್ವರ್ಟ್ ಆಗಿ ಸಾಲಿಡ್ ಒಳಗೆ ಎಂಟ್ರಿ ಆಗ್ತದೆ. ಸಾಲಿಡ್ ಆಗಿ ಎಂಟ್ರಿ ಅದಕ್ಕೂ ಆಮೇಲೆ ಆಕೈತಿ ಕೊಲ್ಯೂಷನ್ ಆಕೈತಿ, ಅಲ್ಲಿ ಮೀನ್ಸ್ ಅಗ್ರಿಗೇಷನ್ ಆಗೈತಿ, ಅಂದ್ರೆ ದೊಡ್ಡ ಕೊಲೈಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತದೆ. ಹಾಗೆ ಕರೆಂಟ್ ಇದ್ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನು ಮಾಡ್ತಾವೆ ಕ್ಯಾಪ್ಚರ್ ಮಾಡ್ತಾವೆ. ಸೊ ಇಲ್ಲಿ ನಾವು ಫ್ರಿಜಿಂಗ್ ಮಿಷನ್ ಅದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಿದ್ದೇವೆ ಅಂದ್ರೆ ಅದನ್ನ ಬಂದು ಅಗ್ರಿಗೇಷನ್ ಆಗಿ ಮಾಡಿ ಏನು ಮಾಡಿದ್ರೆ ನಾವು ಫ್ರಿಜಿಂಗ್ ಮಿಷನ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಪರ್ಷನ್ ಆಫ್ ಮೆಟಲ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ electrical double layer. This is the second reason for the colloidal particles get charged on it. So here the medium which containing many ions, the colloidal particles are adsorb common ion on their surface. The dispersion medium containing many ions, the colloidal particles adsorb common ion on the surface. So consider example, formation of silver iodide by peptidization of Ag with AgNO3 as baptizing agent. Tell me what. So here example is so preparation of silver iodide solution by baptization of silver iodide with AgNO3 as baptizing agent. So what do you mean by baptization? So here the conversion of precipitate into colloidal form by using suitable substance. That is called as baptization. So now tell me what do you mean by baptizing agent? The substance which help to convert precipitate into colloidal form. That substance is called as baptizing agent. So here in this case the colloidal particle of silver iodide, the colloidal particles of silver iodide adsorb Ag plus from AgNO3. We get positive charge colloidal solution. Similarly, by taking another example, for preparation of silver iodide by baptization of silver iodide using potassium iodide as baptizing agent. In this case, so here Agi, the colloidal particle of Agi adsorb I on this surface. Therefore, the formation of negative charge colloidal solution. So here, medium containing many ions, the colloidal particle adsorb common ion on the surface. In first case, Ag is common ion. Therefore, this Ag adsorbed by colloidal particle of Agi. In second case, so here iodine is common ion. Therefore, this silver iodide adsorb iodine on this surface. The combination of two layers of opposite charges on a colloidal particle is known as Helmholtz electrical double layer. So here, combination of two layers of opposite charges. So here, the combination of two layers of opposite charges around colloidal particle. So this is known as Helmholtz electrical double layer. This is known as Helmholtz electrical double layer. Here, the Helmholtz electrical double layer means the combination of two layers of opposite charges. Around colloidal particle. This is known as Helmholtz electrical double layer. So here, consider in first layer. The first layer ions are firmly held and it is fixed layer. First layer ions are firmly held and it is fixed layer. While second layer is mobile, which is diffused layer. While second layer is mobile, which is diffused layer. Depicts the formation of double layer take place. So here, the suppression of charge is set as potential. The charge of opposite sign of first layer and diffuse part of the double layer result and potential difference. This potential difference is similar like in capacitor. So here the potential difference between first layer and diffuse layer of opposite charge is known as zeta potential. But in case of precipitate solution double layer not take place. In case of precipitation solution, the two layers or double layer not take place because there is strong one-to-one force of attraction between two particles. Therefore, in case of precipitation solution, double layer is not take place. So here, this is about the fourth property, charge on colloidal particle. So next, we move towards electrophoresis. So what do you mean by electrophoresis? The phenomenon in which the movement of colloidal particle in an applied electric field. This is known as electrophoresis. So here, the movement of colloidal particle in an electric field. This phenomenon is known as electrophoresis. So here, in this case, the colloidal particle accumulates near to the positive electrode. It indicates the colloidal particles are negatively charged. If the colloidal particles accumulates near to the negative electrodes, it indicates the colloidal particles are positively charged. So this is U2 containing colloidal solution, and these two are platinum electrode. So here, the colloidal solution placed in U2, two platinum electrodes are dipped into the solution. By passing electric current, the colloidal solution move one of the electrode. If the colloidal particles move near to the negative electrode, it means the colloidal particles are positively charged. If the colloidal particles are moved near to the positive electrode, it indicates the colloidal particles are negatively charged. By knowing the direction of movement of colloidal particle, it can be find out the charge on colloidal particle. So notice, colloidal solution U2 को addition ಮಾಡಿರುವ ಇದರೊಳಗೆ ಎರಡು platinum electrode dip ಮಾಡುತ್ತೆ. So ಇದಕ್ಕೆ ಏನು ಅಪ್ಲೈ ಮಾಡಿರೋ ಆ electric current ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. So ನೋಡಿ, colloidal solution ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಕಡೆ ಮೂವ್ಮೆಂಟ್ ಆಯಿತು ಅಂತಂದ್ರೆ, ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಕಡೆ ಮೂವ್ಮೆಂಟ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ? ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಪಾಸಿಟಿವ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅದಾವ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. ಅದೇ ರೀತಿ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಮೂವ್ಮೆಂಟ್ ಆಯಿತು ಅಂದ್ರೆ, ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಮೂವ್ಮೆಂಟ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಇದು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅದಾವ ಅಂತ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಹಿಯರ್ ಟೆಲ್ ಮಿ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಎಲೆಕ್ಟ್ರೋಫೋರೆಸಿಸ್? ದ ಮೂವ್ಮೆಂಟ್ ಆಫ್ colloidal particle in an applied electric field. That phenomena is known as electrophoresis. So here, the colloidal solution taken in U2, the two platinum electrodes are dipped in this solution by applying electric current. If the colloidal particles are positively charged, these particles are moved towards negative electrode. If the colloidal particles are negatively charged, these particles are moved towards positive electrode. By knowing the direction of movement of colloidal particle in an electric field, we find out charge on colloidal particle. So this is about the electrophoresis. Next class we discuss about the coagulation or precipitation, and also method for the preparation of coagulation and precipitation, and also application of the colloidal particle. Thank you.